Hi, welcome to week 7 of Intro to Android Development. I'm so glad that you're still here with us. We're coming close towards the end of the semester, and as we get closer and closer to the Hack Challenge, we are beginning to address more practical topics in Android development that would be useful for someone building a hackathon project, something like that. This marks our 7th lecture, and I believe, given the way the schedule is working, that there will be one more lecture, because the following Monday will be a wellness day, so there won't be any lecture or homework for that week. And I believe the hackathon starts around that time as well, so from then on would just be the hackathon. So I believe it's just this and one more week of lecture and homework. And afterwards, during the hackathon, lectures will continue, but they will be optional bonus lectures. And they will be interesting bonus lectures from guest lecturers on our Android team. Just a little sneak peek, but I think what we've got ready for you guys is one lecture on Firebase Analytics, which is Google Firebase, which is like a way to see how many users are using your app, who's clicking what, and like when are they using it, where are they using it, things like that. And for someone who is making an app where the app is like going to be used by commercial users, this is something that's very important. Additionally, we will have hopefully a lecture a little bit on intro to Android game development and the kinds of libraries you can use, just from a higher level, because that's a very different thing. But you have that to look forward to, hopefully, and if not those, then some other topics that I guarantee will be fairly interesting. So this week what we're going to be talking about is data and data storage, and persistent data storage. So this means, storing data in while you're using the app, or persistent data storage, meaning if I close the app and I open it again, it keeps the data there. So the first topic we're going to be talking about is going to be the most important topic for what we're going to be talking about for the homework for this week. So the first topic is going to be Singleton Classes, and which are commonly referred to as a repository, but just know that the term repository is a little bit loaded, and the usage of it is not always consistent. It really refers to a type of storage, of local storage. So repository local storage could be a Singleton class, it could be, its own database protocol. Repository you can think of as sort of like a pool in which we store the local data into. So when do you want to store things locally? So in the homework you're going to be doing this week, you're going to be storing notes locally. And notes actually in a real OneNote, Google Keep app would not be stored locally, but would be stored in the cloud. We haven't covered networking yet, which will be next week's lecture, but this is something that we're not doing. We're going to be storing locally, and storing locally is a little bit complicated just because it's not something that you want to do all the time, because it can be a little bit susceptible to what if the user clears the app data or something goes wrong. The cloud is usually considered more secure, can be synchronized across multiple devices, and many other things. But so you'll find in real apps that they'll actually be storing onto the cloud, but this storing locally actually becomes crucial to the speed of Android developments. Because imagine if you're pulling information from the cloud, and briefly the internet goes out and comes back on. You don't want the app to just completely lose all data, right? Because the way networking works is there typically are many, very minor interruptions in your networking, right? Especially with Wi-Fi, it'll be connected, disconnected, connected, this sort of pattern. And so for that brief moment of, disconnecting and connecting, right? You don't want your app to just completely shut down. So what a lot of people end up doing is they do something called caching. Caching is when you're going to take whatever data is coming from the network and store it locally for that moment in time. If later on you scroll past that, then you can get rid of the cache. And they're complicated caching protocols which we're not going to get too much into. Just know that this is the general concept at play when people are storing locally. So if you decide to get an internship doing Android development, and they ask if you know about how to store locally or persistent storage, it's probably for caching purposes, not so you can store actual data of the app. Though, you will see things like settings, like if I turned on dark mode in the app or if I turned it off, that will frequently be turned on as a local thing rather than something sent to the cloud. But if you use Google Keep or Microsoft OneNote, you will notice that the data of the actual notes are being synced to the cloud. So that's just a little brief precursor on when, why, and how this is going to be used, this persistent storage, data storage, things like that. So let's talk about Singleton classes. So a Singleton class, well, a Singleton itself is a design pattern. So let's be very clear about that. A Singleton is a design pattern where it restricts an instantiation of some Singleton class to only one instance that can be referenced anywhere. So a Singleton class is basically going to be a class that can only have one instance of it at a time, and can be and you can create an instance of it anywhere in your project. So whether I'm in this screen, that fragment, this activity, doesn't matter. You can access it globally, but only one instance at a time. And this is convenient because it's sort of like a central point of access for an application, which is good if you want to do storage. So that way there's not any conflicting stuff going on. And so imagine if we didn't, let's just pose this thought for a second. What if our Singleton class didn't have this rule where it can only have one instantiation? Then we have the age-old computer science problem of two people writing to the same file at once, or two people writing to the same data set at once. So if I said like x equals 2, but meanwhile at the same time someone else is saying x equals 3, then I've run into an issue. Because now we've got two concurrent threads both saying that x equals something different. And so what order do I take it in? It becomes a little bit complicated. For this reason, only one person can have the Singleton class instance at a time. Okay, so that's one of the first attributes of a Singleton class, is that there can only be one instance, and the other is that it is globally accessible. So the instance of the Singleton class can be accessed anywhere in your project. Okay, these are the two basic attributes that make up a Singleton class. There are also a couple of implementation rules we have for Singleton classes as well. You must have a private constructor. So the constructor of the Singleton class must be private. This is a implementation detail, and it's not strictly maintained, but you should keep this as for good design purposes. The reasons why is to avoid memory leaks and things like that, but it's really a much longer discussion to talk about why we do that, and I believe there should be some links on the course textbook if you'd like to learn more about that. It should have a globally accessible object reference and consistency across multiple threads. These are sort of more complex details, but nonetheless still important. But don't, if you're having trouble understanding them, that's okay. Just stick to the examples that we give you for right now. And I think the more and more experience you get with concurrent programming, as you take 3110, 2110, all of those classes, 4820, I think those sort of topics will become more clear. It's sort of just like an exposure thing. Nonetheless, follow the examples we give on the course textbook. And now let's talk about the implementation. So you can create a Singleton class where it takes in from the constructor an argument of whatever data you're interested in. Could be some data set like an array list or something like that. And especially if in this homework you're going to be following a specific note model. So maybe you'd be using an array list of a note model or a mutable list or some other data structure of the note model, and this is something that you'd want to potentially pass in. You could also go the route of not doing it. These are implementation details. But so you could take it in as an argument to the constructor, and then we can also have fields to our repository class, Singleton Class. And one important field that might be useful to avoid two people writing to it at the same time is maybe just a Boolean flag. So can you modify it? So maybe like a field called moddable, and you said moddable equals true. So no one else has made an instance of it. Or moddable equals false. This is not strictly necessary, but it could be a good idea to make sure that you're safely using the Singleton class as it should be used. And you can also have methods within your Singleton class, some function that does something. And one other thing that's necessary to put in your Singleton class is something called a companion object. Okay, what is a companion object? A companion object is basically it informs how we should make the instance. And when we make the instance, this should be something that can be done from anywhere. So for that reason, that's why we create the companion object. So when someone creates an instance, they have the object that corresponds to it. So if, for example, we had this example with an array list of a grocery list, we would say an array list for the repository instantiation. But this is the basic idea that we want to think about, so that way when you call on the repository, you can do it very easily with just repo equals repository.instance, or if you want to call on some function from there, repository.getInstance from whatever context you're in to do something, and this sort of thing. But of course these vary by the implementations of the repository you use. And we could also do a more simple Singleton class where you just have a private constructor and the only thing you have is the companion object, which could be like a mutable list of whatever data you're storing. And because it's mutable, you can just directly change it, which could potentially be an easier solution, though a little bit less preferable regardless. Okay, the next thing we're going to talk about is going to be shared preferences. So shared preferences is basically a way that we can store relatively small bits of data across the project. So shared preferences is sort of like an API. It allows for saving key value pairs. So what is a key value pair? Think of a dictionary or a hash map, right? Where you have some key and you have some value. And so in this case, we will be storing key value pairs, some key to some value. And it's commonly used for like login credentials, other in-app settings, like if someone turned on dark mode or something like that. And each shared preference corresponds to an underlying file that stores these pairs. But that's looking a little under the hood, I suppose. So you can create a new shared preference file or access an existing one by calling on either get shared preferences or get preferences. So get shared preferences or get preferences. So immediately from the names you can tell that there's going to be something different in terms of the scope. So get shared preferences is what you would want to use if the values you're going to be storing need to be accessed from different activities in the app. So okay, if I have a main activity and a second activity and a third activity, and I want to have access to this to the data in my shared preferences in all of these activities, then I would probably want to use this. And the usage is first creating the shared preferences based off of the context, and it also allows you to have a special, or rather than it allows you, you're supposed to use the shared preferences type when you're creating the object of that type, a shared preference. And I think this is the best way to think about it. Shared preference is an object of type shared preference. and look at this screen, or look at the code on screen if you're not quite sure what we mean by this. And this is the basic usage that you would end up seeing. So so you'll see there's a r.string.preference file key. So this is the key that we're talking about for our key value pair. So remember, a key value pair is like a dictionary, and the key in this case is going to be r.string.preference file key, or whatever it is from r.string. And you only need one shared preferences across your app, so you could use the same key everywhere you get the preferences. And it must be unique, the key. So it's a unique identifier, basically, for that specific file. So, but you could have several shared preferences if you want. Just make sure that you're keeping that uniqueness of the key as one of the qualities of your shared preferences setup. And the second argument you see here is going to be the type of context. So it means that only your app will be able to access the file for context.modePrivate, and is usually what we want. Because, you know, apps, in reality, apps are talking to each other with intents, implicit intents, and things like this, and so mode private is probably what you want, unless this is something you intend on sharing. So get preferences is our other thing. So that was get shared preferences. So get preferences is what we use for a single activity. So once again, get shared preferences is for across multiple activities, and get preferences is for a single activity. So you can think of it as more of a local sort of usage, where you're storing things that are written for one activity, and they tend to be part of one specific aspect of the app, of whatever app it is that you're creating. And we still have the same get preferences, context dot mode private, which in this case would mean the same thing that it meant previously, just the sort of scope of what other apps can see from it. Okay, it's a little bit of a mouthful, but that's get shared preferences for across multiple activities and get preferences for one activity. Okay, so for setting preferences, this is something where each value you store must have an associated key, and so the key must be unique to the value. Otherwise, setting values are quite simple, and so this is how you would do an int, this code right here. So basically what we're doing is we have shared preferences.editor object as our editor, which equals shared preference.edit. And this is what we use if we want to do some editing to our shared preferences. And if you want to put in an integer, you would do that. And there's a specific key for this value, so key value pair once again, and then you have to commit this change. And you could also, instead of putting in an int, you could put in a boolean, a string, a float, a long, and parsables if you have something complicated. So there are all sorts of different things that you could put in your shared preference. And reading preferences, likewise, is pretty similar. You retrieve it, but you need the key in order to do so. So you would have your shared preference, and you'd say .get something, the key, and then whatever the default value is if the key is not found. So this is sort of like a safety. So in case the thing you're looking for isn't there, there's a default value to fall back on. And you'll notice that this syntax is very similar to intents and how we dealt with bundles and things like that. And this is true, and they were designed this way on purpose because it's sort of become an idiomatic thing, and shared preferences came after bundles and intents. Okay, the next thing we're going to be talking about is something called rooms. So we're not going to need to do any implementation with rooms, but rooms are preferred over Singleton classes and that sort of mode of data storage. And they're more supported by Google, but they are significantly more complicated. But if you're going to do a complex backend in Android, this is definitely what you'd want to do. It allows full database customization, use with SQL, SQLite, things like that. But regardless, let's talk about rooms. So the sort of pitch for rooms is, what if you wanted to store more complex data? Or rather, the structure of the data is more complex that you're trying to store. It's not just like a straightforward list or something like that. And then you could sort of find a way to do it with shared preferences, but it would introduce bugs and, So Android's solution is the room library. So if you want to use the room library, you have to add the library in your build.gradle. And you also have to add something in your build script, which we can link for you on the textbook website. But there are 3 basic aspects to it. So there's going to be our first aspect, which is our entities. Our second aspect is going to be our data access objects, and our third aspect is going to be our databases. So first off, what is an entity? So you could think of an entity object as representing a table in a database, where each field corresponds to a column. So you could define an entity for like a grocery list, or for a notes list, or the possibilities are innumerable. But it's basically as you think. So you have a grocery item entity, and so like this dot item, this dot brand, this dot number, all of these would be different columns in your data. So an item column, right? A brand column, a number column. These are all important aspects of your grocery item entity. And this is basically all there is to it. It's just sort of thought of like this, where you have a basic sort of column structure, and you can think of it like a table. The only thing is we must say the type of it, so if it's a string, if it's an integer, and one of them must be your primary key, where each one will be unique. So if I'm doing a grocery list, maybe I'd want that not to be the brand, right? Because the brand could not be unique. Maybe I got Kraft peanut butter and Kraft cereal, right? So cereal and peanut butter are unique, the item is unique, but the brand is not unique. So you would not want that to be your primary key. Okay, now let's talk about data access objects. So what a data access object is it's basically, or DAO for short, it's basically how we interface with the data, how we interface with the entity. So the data access object is going to be how we can push changes to it, how we can, or also known as inserting, how we can update the data, how we can delete elements of the data, get elements of the data, things like this. These are done using our data access object, and they're sort of like an object in which you access the data. So if you rearrange the words, I typically think it makes a little bit more sense. And you can use more advanced SQL if you're familiar with databases, with your data access objects, but if you don't know what that is, don't worry about it. But regardless, this is not something we will be testing in the homework anyways, since for the homework you will only need to know the implementation of a Singleton class. But this is the basic idea that motivates a data access object, and the last thing is just the actual database itself, which is responsible for doing a lot of the heavy lifting of storing, sorting, filtering, and things like that through the data functions of the data access object. So in your data access object, right, it's an object to access the data, but who's doing the heavy lifting there is actually the database itself. So it allows the data access object to work. So you can think of the data access object as sort of like a bridge, and the database is the destination of that bridge, or the base home from the bridge. And you can read more about the general implementation of how to access a database, and things like that, and async tasks and things along those lines, and doing things on different UI threads. But we're sort of going to cut it a little short here just because we're sort of entering deeper waters than we need to, especially for the homework. But nonetheless, if you have any questions about it, do let us know. It's something we could definitely try to maybe put in something in like a guest lecture about if this is something that you guys seem interested in. But this is going to be the end of this week's lecture. Just to recap, we talked about Singleton Classes, which are basically like a class in which there's only one instance of at a time that is available globally. And this is good because it's a central point to make changes to data in our app. This change does not happen permanently though. When you close the app and open it again, it won't take place. Shared preferences is a good example of keeping data across different activities or maybe for one activity. And you could also be using the room library of entities, data access objects, and databases if you want a more robust system but is a little bit more complicated. Follow the textbook for further instructions if you'd like to go down that route. But regardless, this will be the end of this week's lecture. Thank you guys for staying with us, and I'll take it over to Jesse. Thank you guys.
Hello everyone, welcome to the 7th week of Android development. This week we're going to have a demo about a singleton object and shared preferences. I have set up a main activity for you guys just for demoing purposes. I have a text view that has the ID of test. So I'm gonna use it to kind of show you guys how data changes over time. And I also made a reference in the main activity before everything have started. So let's first start with Singleton Classes. As you guys have probably learned in the lecture, Singleton Classes has one private instance and it is accessible across all different kinds of classes. So let's try to first create a Kotlin class. And let's just call it repository. Let's just say class repository. And as we said, it will have kind of one instance, but it's like a private instance. So we kind of don't want people to be able to create like a lot of instances by themselves. So is this constructor is just gonna be a private and empty constructor. Because not every class can create an instance of repository, we're just gonna have one default instance of repository, and it's just basically like a companion object of the repository class. Okay, now we're going to give this repository instance some field, and let's just say we can have a variable that's named, let's say, just grocery. Okay, and let's say the grocery at this point, we'll name it like the value of it will just be initialized to Apple. What if you wanna like other class wanna get this instance of repository? We will create a method called getInstance. And getInstance is supposed to return this companion object that we were talking about. Basically, is the one and the only instance of repository. So the return type will be repository.companion, and we will return repository companion. After that, you may ask, what if I want to change the field of this companion object? Well, we can, for example, create a function that says like set text. So we can set whatever the grocery, actually let's just say set grocery. Because in your case, you might need to have a companion object with like multiple different fields. But let's just say like set grocery. And the parameter of set grocery, you will need a text inside of it. So it will be like text and string. And let's say grocery equals to this text that you created. Okay, what if you want to, like, now you have set grocery, what if you want to get what is inside grocery? You can do function get grocery, and it's gonna return, I guess, a string value. That's whatever the grocery string has the value to. And let's just say return grocery. Okay, so this is just the basic structure of a singleton class. For like the field of companion object, you can have like a lot of different types. For example, you can have a mutable list, or you can even have like an object of other classes. But in this case, for simplicity purposes, we're just gonna have a string. So let's see how a class would sort of work with the singleton classes. Okay, so in the main activity, I can do repository get instance. In this case, it's just gonna get me the one and the only instance that repository class has. It's basically the companion object. And let's say repository get grocery, and we're gonna, so in order for us to see how data changes, we can set the result to a text that I just created before this. Okay, so now the text is set to Apple. It was originally Hello World, now it's Apple. Okay, what if you don't want a grocery of Apple? So let's say you wanna set it to banana, and get this, let's just get this text again. And now it's turned into banana. The advantage of this is you can use it in like you can call this class, and you can change the instance in every class of your program. Another thing that could be very similar to singleton classes is what we call shared preferences. If there are many data that you want it to be accessible across multiple classes, you may want to use shared preferences rather than a singleton class. Okay, now I'm going to create a second activity. Let's say we create a shared preference in the main activity. Okay, so the get shared preference takes a string and a mode. So the string is basically kind of like a key that tells you which shared preference you want. Basically, each of the shared preference is kind of stored in a local file on your phone. So we kind of need to give it kind of a key, and let's just name it, let's just name it like shared preference 1. And for mode, let's just say mode private. So how do we add data inside this shared preference? Well, we use something called shared preference editor. And it's going to be set to sp.edit, so you will know like which shared preference is this shared preference editor editing. Okay, so this editor, we can put string, we can put int, we can put long, like we can put a set of variables inside of it. And let's in this case just put a string. So the first parameter is just going to be the key, and the second parameter is going to be the content that you want this key to be related to. Let's just say the key of this string to be fruit, and the value to be apple. And let's also put an integer inside that says count, and let's just say a number of 3. And after you add whatever value, you change whatever value in the shared preference, you say editor.commit to kind of just like save and finish everything inside the editor. Okay, so how do you access it? Let's say you want to access this value in the main activity 2. So also I'm just gonna create a text view inside main activity 2 so you can see the result better. I'm just gonna copy it from main activity 1. Okay, and let's then also get the shared preference here using the exact same code. And in order to get the value, we can just say sp get string or get whatever value you want. So now you might be a little confused why for get string there will be 2 parameters. Basically, the first parameter is just gonna be the key, and the second parameter is gonna be a default value. So if there's no value corresponding to the key that you provided, you kind of have to provide a default value saying that okay, if there's no value, the return value is just gonna be x. So let's just say in this case, let's just try to just assume that there's a value for fruit. So for default, I'm just gonna have like an empty string or something. And let's just set it to the text view. Also, I'm gonna also add the count. We'll just check if it's capitalized or not. And let's just say the default is -1. And just also add an empty space in between. And also we have to go from the main activity to the second activity. So I'm just gonna quickly create an intent. Okay, so once the main activity start, it's just gonna go directly to the main 2 activity. So the first activity that we're gonna see is gonna be the main 2 activity, even though that everything here has already been run by like the program. You wouldn't see it because it's just gonna be like super quick. So let's just run the emulator and see if we can get the result we want. Okay, we see apple and 3, so both of the values are passed. And let's also say like something, we can say like vegetable, which is not really something that we have put in the shared reference. Let's say the default value is none. In this case, it's just gonna be none and 3 because there is no value that has the key of vegetable, so it's just gonna be default to none. Okay, this is everything in the 7th lecture demo. Thank you guys for listening and have a great week.